Alright, if you did not finish your quiz, you can keep working on it, but we're going to move on to 1.6 notes. And make sure on your warm-up you put finishing quizzes today. We didn't do a warm-up today because I want to make sure that I have as much time to finish as possible, but we do need to spend the last 20 minutes on notes 1.6, which should be in front of you, okay? So if you don't have it, I'll get it to you. Alright, so again, if you're finishing your quiz, do that. Cool? So finish your quizzes, right? And maybe Miss Morrow can help you if you're not able to finish, because we need him to finish day 2. So maybe he can go over to you. I don't know. Does he need to sit with you? Do you want him over there, or you want to go to him? Just that one. She's doing fine, but he's not. No. Okay. Alright, so look at 1.6 notes. So the name of this tells you what we're doing, right? But we're going to be talking about quadratic functions. Now, do y'all remember talking about that in Algebra 1? Okay. What does a quadratic graph look like? What shape does it make? Y'all remember? Kind of looks like a U. And what is this thing called? It starts with the letter P. Parabola, okay? So if you have a quadratic function, it makes a parabola. Parabola. Okay? So here's our objectives for today. And we're down here. Okay? So there are things called square numbers. Okay? And by the way, we're doing notes. I want headphones out of our ears unless you're taking the quiz, right? So square numbers are numbers that if you had little, what are these called? Counters, you could make a square out of them. So if you have one counter, that's a square, meaning it's 1 by 1. If you have 4 counters, that's square because it's 2 by 2. 9 counters, 3 by 3. And then 16 counters is 4 by 4. Okay? So the number 1 is square. The number 4 is square. The number 9 is square. The number 16 is square. That makes sense? You can make a square out of them with counters, right? So, what pattern do you see in the geometric arrangements? Okay, so the pattern, what's being added each time is a row and a column. Does that make sense? So like you had 1 row and 1 column. There's overlap there, but okay. 1 row and 1 column each term. Okay? So it's not really adding a single number each time, it's adding a shape, a certain layer, so to speak. Okay? So those are square numbers, and now we're going to do the explore at the bottom. Okay? So at the bottom it says a figurative number, also called a figurate number, okay, is a number that can be represented by a regular geometric arrangement, okay? Meaning it makes a shape. So if square numbers make a square, what do you think these numbers are called down here? Yeah, triangular numbers make a triangle. And by a triangle we mean a regular one, meaning the same side lengths, okay? So down here, we have 1 counter. Then we got 3 counters to make a triangle. Then we have 6 counters to make a triangle. And then we got 10 counters to make a triangle. So do you see how the numbers are going? 1, 3, 6, and 10. We're going to put those on the next page on the table. Okay? So if you flip it over, it's asking us, hey, fill in this table of triangular numbers. Okay? So once again, the numbers were 1, 3, 6, and 10. So we already have 1. The second term is 3. The third term is 6. The fourth term is 10. Okay? So, now, what's happening each time is we're adding a layer, right? So we started with 1, then we added 2. Then we added 3. Then we added 4. So guess what we're going to add next time? 5, right? So the next one will be okay, so if you counted all that up, if we added 5 to 10, we get 15 counters, okay? Now, if I added 5 to that, the next one I'm going to add 6. So if I counted up all those counters, I'd get 21, okay? So again, we're just filling it out with the triangular numbers, and the last two we had were 15 and 21, okay? So, number 1 asks us, as you build the sequence, what patterns do you see in each term, okay? So each term was adding another layer, okay? But was it adding the same number each time? It was adding 2, then it was adding 3. So it's increasing by a number, but it keeps increasing and adding 1. Does that make sense? So it's not increasing by the same number, it's increasing by a number plus 1, right? So what patterns do you see? It's increasing by an amount plus 1 each time. It's like taking the former amount, adding 1, right? Okay, so how do we tell if it's linear or exponential? So if you remember from what we've been learning, okay, to find out if it's linear, we have to subtract and see if they're all the same, okay? So let's subtract these numbers and see if we get the same number. See if it's linear. 3 minus 1 is? Okay, and then 6 minus 3. So is it linear? You can already tell it's not the same, right? So let's finish it off. 10 minus 6 is 4. 15 minus 10 is 5. 21 minus 15 is 6. Okay, so not linear because, okay, explaining it, the differences differ. The differences are different. They're not the same differences. They're not the same subtractions, right? So that's how to tell if it's linear. Get that down over here. But we need to tell if it's exponential. Now, what did we do with the numbers to tell if it's exponential? Dividing, okay? So if we divide the two numbers and they're the same, then it's exponential. So we're kind of same thing, we're just bringing it way over here. So 3 over 1, what's 3 divided by 1? Okay, and then 6 divided by 3, 2. Is it exponential? You can already tell that it's different when we divide, so it's not exponential, okay? And we can keep going. We could do 10 over 6, which is 5/3. 15 over 5, which is 3/2. 21 over 15, which is 5/6, I believe. No, 5/7. So, all that to say, it's not exponential. Exponential, because division, actually we'll say the ratios. Exponential. The ratios differ. Not exponential, the ratios differ. So if the differences are different and the division, the ratios are different, it's got to be something else. It's not linear, it's not exponential. Okay? So, the next question, okay, I'm going to do this in blue. Excuse me. What patterns do you see in the finite differences? So, right here, this column, is there a pattern? So, follow with me, right? If you're not on your phone or listening to music, you're up here, right? So, 2, 3, 4, 5, 6. Is there a pattern there? Yeah, it's adding 1 each time, right? So, if you see a pattern in the differences, okay? So, let's write yes first. What patterns do you see? Adding 1 each time. For the differences, not the ratios. The ratios, there's nothing there for us, okay? Now, this is the new thing we're learning today. Now, maybe you learned this in Algebra 1, cool, but you got to know this, okay? How do you tell, again, for these notes, quadratic, right? How do you tell if something is quadratic from a table? Notice number 4. I want you to underline this big time, right? Everyone's heads up, right? So, calculate the second finite difference. Okay, big underline. That's super important, okay? What we're going to do is we're going to take these differences right here, and we're going to do another set of bird beaks, or whatever you want to call them. We're going to find these differences and see if those are the same. Okay? So we do differences, and if there's a pattern, we do the differences of the differences. Okay? We call it the second finite difference. So let's do this. 3 minus 2 is? And then 4 minus 3. And then 5 minus 4. And 6 minus 5. Is the second finite difference the same? Is this all the same? Yes. If the second finite difference is all the same, that is what we call today quadratic. Okay? So, what did we notice? The second finite difference are the same. I'm running out of room. If you do, oh well, try to write the best you can. So if the second finite difference is the same, that is quadratic, okay? And remember, quadratic makes a parabola. It's not exactly a U shape, but it kind of looks like a U shape, right? Okay. Now, do you know this? Quadratic parent function is y equals x squared, right? What makes something quadratic is that the x is squared. What makes it quadratic? When x is what? Squared, okay? That's how you can tell. Okay, now it wants us to generate a sequence with the y values when x is 1, 2, 3, 4, 5, 6. Well, we got a little help below. There's a table here that tells us all the y values. So just for this one, we're looking right here to help us up here, okay? So what's the y values all the way down here? 1, 4, 9, 16, 25, 36, okay? Now, they wanted you to do that yourself, but You know what squared means, right? Times the same number. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36, right? Right? So, here's where you're going to do a little work, okay? It's what we just did. I want you to find, on number 6, find the differences, and then find the finite differences. The second finite difference, okay? So, again, do y'all see what I did up here? Find the difference and then the second difference. You're going to do that at the bottom, okay? And I'm going to walk around and help you if you're stuck. So everybody, go ahead and do that right now on number 6. Find the second difference. The numbers we got were 3, 5, 7, 9, 11. And then the second difference, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2. The second difference is 2, okay? So what does that mean? What kind of function is that? It's not linear or exponential. It's a new one today, and it's on the front of your notes under 1.6. It's quadratic, okay? So that's what number 7 is asking you for at the bottom of your page. So at the bottom, we're on number 7. I know there's not a lot of room. Quadratic. It's asking you what kind of function, okay? Okay. Cool. So we're going to use this to do an assignment tomorrow. Remember, second difference, if that's the same, it's quadratic. Okay, remember that. Cool.